Welcome to my video on graphing complex numbers. In the rectangular coordinate system, we know how to make a plot of an XY coordinate system. It's just real simple. We go over X number of points and up Y number of points, and there's our graph. But in the complex number, if we've got a complex number, Z is equal to A plus IB, that becomes a little more involved. So what they've come up with is a thing called the complex plane. What it is, it looks like just your standard XY coordinate system, except it's labeled differently. This is going to be the imaginary axis, and this is the real axis. So what you do is on what used to be your y-axis, it's going to be like I, 2I, 3I, on and on, minus I, minus 2I, and then minus 3I, and then on and on. And on the real axis, it's just 1, 2, 3, 4, and then same thing with the negative, minus 1, minus 2, minus 3, minus 4. So the real axis is very similar to what we used in the x-axis in our xy coordinate plane. The imaginary axis is just everything's multiplied by an I. So let's look at an example. Let's take 3 plus 4i. So the real part is the 3. So we go over 3. And the imaginary part is 4. So it's 1, 2, 3. There's your 4i. Over there, just like we did in the xy coordinate plane. So there's going to be our point. That's going to be 3, 4 on the complex plane. Now if we draw a line out there, we're going to call it r because it's going to be the magnitude. So r is going to be equal to the magnitude of the complex number. And we know from previous work that the magnitude is going to be equal to just the a squared plus b squared, the root of it. So that's going to be the distance from the 0 point out to this point, 3, 4. So there's some of our basic ideas on the complex plane. Now let's do the example, graph minus 2 plus 3i and its conjugate on the complex plane. So here's our imaginary number. Z is equal to minus 2 plus 3i. Z conjugate, we just changed the magnitude of the constant, or the sign in front of the constant in front of the imaginary portion, so it's minus 2 minus 3i. Now the magnitude for both of these is going to be the same because it's just, since we're squaring a squared plus b squared, in this case it's the square root of minus 2 squared plus the square root of, really just plus or minus 3 because the 3 changes, but still going to be a 9. So 4 minus 2 squared is 4, plus, and then 3 squared or minus 3 squared is still 9. So our result is square root of 13. Now let's plot this on the complex plane. Here's our real portion, our real line, imaginary. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's some tick marks to help us work with. So the first one is we're going to do the real part is minus 2. I'm looking at this one first. So there's minus 2 on the real axis. And on the imaginary axis is going to be a plus 3. So 1, 2, 3. So it's right here. So that's going to be our first. So that's going to be the minus 2, 3. That's going to be z. Now, for z conjugate, we're going to do minus 2 on the real axis again, so that's the same point there, except this time we go down 3. 1, 2, 3, and there is going to be z star, and it's going to be at the point minus 2, minus 3. And you can see the conjugate is going to be symmetric about the real axis, which makes sense. Now, what I've done here is what's called rectangular form. But we're getting ready to do some more videos on the polar and exponential. So they're going to be next, or very soon. And we can see how we can plot these numbers, these complex numbers, in rectangular, which we did here. And there's also polar and exponential. Those are coming videos. I hope you learned a little bit about graphing and this complex plane. If you did, give me a like, thumbs up, subscribe to my channel. Thank you for watching.